Hello everyone, welcome to lesson number 10. So today we are doing AnalogWrite. So on our info slide today we have lesson number 10, AnalogWrite. So usually Arduino operates with 5 volts output, so it's usually 0 volts or 5 volts, 0 representing off, 5 volts representing on. So this is when you're working with the digital wire, with the digital write I mean. So for digital write, you can only operate from 0, which will be low, and from 5, which will be high. So in analog write, you can vary any voltage you want as long as it's between 0 voltage and 5 voltage. So in analog, 0 voltage is represented in the with the value 0 in coding, while 5 voltage is represented with the value 255 in coding. So when you're doing a digital write, you can perform from 0 volts up to 5 volts. 0 volts value 0 and 5 volts represented by the value 255. So you can actually use values like 300 and you get the corresponding voltage out. So to calculate the output voltage, or to get the corresponding value of the voltage we use the formula V out is equals to the value, that is the value between 0 to 255, divided by the maximum, which is 225, multiplied by the 5 voltage as the maximum output. And there we have our output value. So we will put any number between 0 to 55. So what I'm saying is you can create an output voltage of 3.3, 2.5, whatever value you want while using the analog write. Okay, so let's put this in an example. So here I have set up these connections. There's nothing fancy with it. It's just the normal LED connection, except this part. Last time we're taking from when we were doing digital, right? We took from the digital pins. This time I took from the analog pins. So our power pin here is A0. As you can see, it will be delivering power to this positive track, where this resistor will be connected here, and the positive leg of the LED takes the power here, and the other one is in this negative ground strip, which is connected to ground right here. Okay, so now let's go to the code. So for this one is a very simple code. I've already done it. So first we declare our pin, our LED pin, which is A0, this one. This DT, this one is delay time 500, which is half a second. So we do our pin modes, and we are letting it output. So here now we do an analog write LED pin, meaning A0. In digital write, would after this comma would write high or low. So in this time I'm writing 255. This is same as high, for this is 5 voltage output, in a delay of half a second. And this time I'm doing another analog write of a LED pin, and I'm writing the value 10. This will be a low voltage output. Usually this one is not even enough to make the LED light. Another delay of a quarter of a second, analog write LED pin 150. Well, this one is not maximum, but it should be enough for our LED to light. You should notice some change in the brightness of the LED. Right, so what is going to happen when I upload this code is our LED is going to be on. After half a second, it's actually going to go off based on this this code. Then after a quarter of a second, it's actually going to go on with a lower brightness. Then after half a second, it goes on. So this will happen repeatedly. So for now, let us upload our code. Okay, so our code is now uploading and done uploading. So now let's maximize here. So exactly as I described in my code. Okay, let me do this. So as you can see from these values, it is spending half a second with full brightness, and it's just going to blink for a quarter of a second and then spend half a second with low brightness, and the cycle repeats. Oh, unfortunately my LED, you may not actually see the difference in brightness, but different voltage is being sent to this LED. So this will be all for analog write.